Hey, this is Mrs. Slauson, one of the Algebra 2 teachers, and here is your review for Chapter 6, Part 2, Log Functions. All right, the first part you do need to note is no calculator, and on the test we're going to have a calculator and a no calculator part. So on the first problem, we are going to write the single log function as a sum, difference, or product of individual logs, which means we're going to go from one log and expand it into several logs. So if you kind of just in the first problem, ignore this ln right now. What you want to do is look at this 5x cubed y squared as 5 times x cubed times y squared. And what we talked about is that this multiplication will be turning into addition when we expand it. And then basically what happens is these three terms are separated by addition and subtraction, are going to get that ln that I crossed off right in front of it. So it's going to be natural log 5 plus the natural log of x cubed plus the natural log of y squared. And then what was talked about in your class is that these exponents, the third power and the second power, aren't going to stay where they are. They're going to move to the front. Right here, and this one's going to go right here. So when you're done, the final answer is the natural log of 5 plus 3 times the natural log of x plus 2 times the natural log of y. And now you've expanded this as three terms that are connected by a sum with addition. Okay? All right, the next problem, so B. So again, I'm just going to ignore the log. And we're not used to expanding when there is a radical. So the first thing I want to realize is that a fourth root is the same as a 1/4 power. And then I'm going to go back to my rules of exponent and remember that this exponent can distribute to the y's and to the x. So now I'm going to look at as x to the 1/4 times y to the 1/4 power, and then that is divided by 7. So again, what we're going to do is expand this. So this multiplication that you see is going to turn into addition. Whoops, that was supposed to be a different color. Here we go. And then this division bar that you see is actually going to turn into subtraction. So what I'll do is bring this log back. It's going to be log with x to the 1/4 plus log and y to the 1/4, and then minus log 7. And again, to fully expand this, these exponents are just going to move to the front and turn into multiplication. So our final answer for this one is 1/4 log x. I'm just going to write it for you. 1/4 log y minus log 7. So what's in purple? This is your final expanded log. All right, on C. So on C, what I'm going to do, again, just temporarily, I'm going to ignore this log and focus on the thing that's left. And what I want to do is deal with these parentheses. This exponent of 3 is just going to distribute to both parts. So we want to look at this as x to the 12th. Remember, you multiply the exponents, and y to the 3rd. And now I'm going to turn the division into subtraction. So this division bar is just going to turn into subtraction. So when we're ready, this is going to become bringing the log back. Let's get a different color here. No, that works. It's going to be log x to the 12th. And now maybe you're realizing, you don't need to do all these little steps, that this 12 can actually just move straight to the front and go right here and not even have it here. So I'm going to erase that. Minus, I forgot my little base of 3, and then log base 3 of y cubed. And again, maybe you're going to remember that that 3 goes into the front. So I'm going to rewrite it below, running out of room. And there's your final answer. So those are the first three problems. Now in the second part, we're going to do the exact opposite. We're going to go from having several logs and we're going to condense it down into a single log. So we're going to do the exact opposite. So the first thing I'm going to do in A is anything that's multiplied to the log in front, like this 2, is going to go back as an exponent. So that'll actually be, we should look at that as 6 squared. So I'm going to cross off this 2 now. And then if you just ignore all of the logs, so just kind of cross these out, and you see this 5 plus 7 plus 6 squared, this is where the multiplication is just, I'm sorry, the addition is going to turn into multiplication. So these become multiplication dots. So it's going to become 5 times 7 times 6 squared, which I'm just going to go ahead and turn into 36. Now, on the test for this particular problem, 5 times 7 times 36 would take a little bit longer. So, for instance, if you wanted to, you could just write it as 35 times 36 and then bring that log back. But if you really want to know what 35 times 36 is, we're going to cheat and actually type it in. So this is an okay answer, but technically the final answer is we want to simplify as much as possible. It would be the natural log of 1,260. Okay? All right, on B. So again, the first thing I'm going to do is take anything that's multiplied to the front and move it back as an exponent. So that 3 is going to become 13 cubed, and that 3 is going to become x cubed. And then what I'll do is just kind of just ignore these logs, and I want to look at this 13 cubed minus x cubed. Well, that subtraction sign is now going to turn back into division. So it's going to be 13 cubed over x cubed, which without a calculator, you might not know 13 cubed. So one option for your answer is bring the log back and leave it as 13 cubed over x cubed. And the other option is if you want to take the time and find out what 13 cubed is, it's just 2,197 over x cubed. And there's your final answer for B. And C, again, first step I'm going to do is just take the numbers in front, move them back as an exponent, so the 18 becomes x to the 18th, the 6 becomes y to the 6th, and then just ignoring the logs, I want to look at this as x to the 18th over y to the 6th. I can't do anything to simplify here because the bases are different, so just I'm going to bring the log back, and there's my final answer. So problem 1 and 2 were working opposite of each other. In the first set we were going from 1 log to many logs, and on the second problem we were going from many logs just back down to 1 log. All right, 3 and 4, this is the very first thing that we talked about in the chapter. We're just going to write it in its equivalent form. So you learned a trick about maybe a cursive E or making a block L. So that's what I'm going to do on the first problem. I have a log and I have to write as an exponent. So you always start with the base, and the base here is 6. So it's going to be 6 to the 3rd power equals 216. And with an exponent table or your calculator, you could double check that that's correct. So this is the exponent version of the log. And then on B, again, this is a log, so I'm going to turn it into an exponent. So in the first problem, the base was 6. When you see the natural log, there's an understood base of e here. They don't write it, but that's what's implied to be here. So again, if you start with the base, you're going to have e to the y power equals 2x. All right. So on 4 and 5, what we're going to do is turn them from exponents into logs. So this is where I need to make my capital block L. And then the biggest mistake that might happen is you actually just forget to write the word log. So I'm going to put the word log on both of them because I got to turn them into logs. And I start with the base. So remember, the base of the exponent is the base of the log. And the base of the log is this little number that goes right here. So always something that's the same. All right. So I'm going to start with my base log, write a little m, and then I keep going over normal sized n of n equals 3. And then you can finish your block letter. So on this one, start with log base e of 5 equals 3y. So this is not the answer we're looking for, though. Remember, log e is an ln. So this is the answer we'll be looking for on the test, okay? But if it's easier, start out with the and then move into this one.